Hey everyone, welcome back to another explainer. Today we're unpacking a tool that is literally reshaping how developers interact with AI agents. We're talking about ECC. It's an MIT licensed project that completely revolutionizes multi-agent development by acting as a universal operator system. Look, if you build software today, you already know that AI coding assistants are absolute game changers. But let's be real, managing them has become a surprisingly heavy lift. So let's get right into how ECC solves that whole mess. Let me start off by asking you a slightly provocative question. How many AI agent configs are you actually maintaining right now? Seriously, think about it for a second. You probably started out with Claude Code for your main project. Makes sense. But then someone else on your team adds Cursor for a second repository. Next thing you know, you're wiring Codex into your CI pipelines. Before you even realize what happened, you are totally drowning in configuration files. Okay, here is our roadmap to see how ECC fundamentally changes your workflow. We'll start with the config drift problem, move on to defining ECC as an operator system, peek inside the component engine, really unpack the MCP advantage, explore the cross-harness reality, and finally clarify the local OSS versus hosted pro tiers. Let's do it. Part 1, the config drift problem and the pain of multiplying harnesses. Let's just address the reality of modern development right now. Our AI tools are silently fracturing our workflows. The practical symptoms of this config drift are honestly so painful. Like we just talked about, you add Claude Code, Cursor, and Codex, and suddenly you're doing all this manual duplication. A /review command might work perfectly in your Claude Code setup, but then you jump over to Cursor and it's completely missing. You end up with duplicated MCP server JSON files that have these annoying slight formatting differences. And honestly, the worst part? Zero shared memory. The learned patterns from one coding session just do not carry over anywhere else. Moving to part 2, ECC as an operator system. This is a fundamental paradigm shift. To really grasp how to solve this, we have to completely shift our mental model. This is not just about tweaking a few JSON files. Look at the stark contrast here. A standard config template simply tells a single harness how to behave. It's a one-to-one relationship, but ECC is an operator system. That means it defines your skills, memory structures, hook events, rules, and MCP configurations in a shared foundational layer. Multiple different harnesses consume that exact same layer simultaneously. You write it once, and literally every tool you use gets smarter. And having this shared layer enables some incredibly powerful features, like what ECC calls instincts. By using a simple /learn command, your AI can extract behavioral patterns right in the middle of a session. And these aren't just temporary context that vanish when you close your laptop. They become persistent instincts that carry across entirely different sessions and IDEs, and they operate with a 30-day time to live. So your AI actually remembers your specific coding preferences for a whole month across every tool you use. All right, part 3. Inside the component engine. Let's look at the sheer scale of the open source layer. We're popping the hood now, and the raw power of this MIT licensed system is just wild. One single install instantly gives you 79 commands out of the box. Think things like /verify or /orchestrate. You also get 183 reusable behavioral skills, over 20 hook scripts handling session boundaries, 34 rules for languages from TypeScript all the way to Go, and 14 completely pre-configured MCP server entries. It's an absolutely massive jumpstart for any dev team. You don't have to build any of this from scratch. Which brings us to part 4, the MCP advantage, and streamlining the model context protocol. This is really the core focus of our explainer today. If you're building with AI agents, you are definitely using MCP to connect to external tools. And ECC completely revolutionizes how we manage this. Let's say you're wiring up a Superbase backend deployed to Railway. Normally, that means manually writing out custom MCP server configs and hooks. With ECC, those JSON entries for Superbase and Railway are already pre-written. All you do is drop in your local API credentials and boom, the connection is live. Then you just run a /QualityGate command before deploying. It removes all that abstract configuration friction. But we need to talk about a hidden danger with MCPs that nobody really mentions. As the official documentation warns, too many MCP servers will absolutely eat your context window alive. Every single MCP tool description consumes tokens from your 200K window. If you aren't paying attention, leaving all those unmanaged tools enabled can drastically shrink your massive 200K context window down to just 70,000 tokens. Yeah, you heard that right, 70,000. Every tool description eats into the AI's memory, which severely limits its ability to actually reason about your codebase. To prevent this kind of hallucination and memory loss, ECC enforces some strict token optimization guidelines. The golden rule? Keep it under 10 enabled MCPs, and strictly limit yourself to under 80 active tools per project. And ECC makes it super easy to toggle these off at runtime using a quick /MCP command. It even persists those choices so you always preserve that valuable token space. Okay, part 5. Cross-harness reality. Let's explore the universal architecture.
So how does this single engine actually adapt natively across the entire ecosystem? Well, you can see it right here. Claude Code is the native target, so it gets the full 8-hook surface. Cursor, though, utilizes a really clever DRY adapter that essentially naps its 15 distinct hook events back to the shared Claude script so you don't repeat yourself. And OpenCode integrates seamlessly while bringing 6 of its own native custom tools to the table. It is a truly universal setup.
Under the hood, the secret sauce making all this magic happen is the root agents.md file. That acts as your universal cross-tool source of truth. From there, those clever adapters, like the dry adapter for Cursor or the JSON auto-merger for OpenCode, step in. They completely prevent you from ever having to rewrite your logic for each specific IDE. And finally, part 6, local OSS versus hosted pro. Let's quickly clarify the product tiers. As we wrap up this explainer, we really need to distinguish between what runs on your local machine and what runs in the cloud. The ECC OSS tier is completely free and MIT licensed. It's a local NPM package that gives you all the core agentic tooling, the shared hooks, the skills, and even a local tkinter GUI dashboard. ECC Pro is a different beast. It's a paid, hosted GitHub app. It adds heavy-duty CI/CD capabilities, private repo analysis, and PR-triggered security audits powered by a tool called Agent Shield. So they're complementary, definitely not interchangeable. I'm going to leave you with this final provocative thought. Is your team ready to stop configuring and start actually operating? I mean, why waste hours maintaining 7 different constantly drifting configs across Claude, Cursor, and Codex while simultaneously burning through your MCP token context when you could literally install one unified operator system today? Think about it. Thanks for joining me for this explainer, guys. Now go out there and optimize your agents.